What we're working on today is equations from tables, okay? If you remember back in 6th and 7th grade, we had input-output boxes, okay? Well, some of you remember. Last year you remembered. So this is our input right here, okay? That's your input. This is your output over here, okay? Well, what are you putting it into? You're putting the x, or the 1, into the equation to figure out what comes out. That was your gears, if you remember. So when I put the 1 in here, it's a -5 times 1 minus 2. That's a -5 minus 2 is a -7. Notice that equals a -7. We have a -7. Okay? In this problem, what it's asking and showing you, it's showing you what the equation is. It's asking you what is 2 going to equal when we put that in. What's going to be the output? Okay? Some terms or names I'm going to throw out there just so you start to hear them. This is also your domain. Okay? Your x is your domain. That's your input. And range is your output. That is the f of x, or if you remember, this is y. F of x is equal to y. They're the same thing, just different notation. Just like 3/4 is equal to 6/8. Just different notation. Different name for the same thing. Okay? So we substitute 2 into our equation there, or in this case, it's actually a function notation, but we substitute the 2 in there, and we get a -5 times 2 minus 2. That's a -10 minus 2 equals a -12. This answer is a -12. Sometimes the input they give you will have a pattern. In this one, it doesn't, because it goes add 1, then it adds 3, and then it adds 2. But sometimes there'll be a pattern there. Okay? Then over here will also follow a pattern. So if your input has a pattern, your output will have a pattern. Anyways, in this case, it doesn't happen. That is your answer. So in Khan Academy, in your little box, you would put a -12. Okay? Let's try the next one. In this one here, it's asking which equation satisfies the table. So we just start with the first one, 4x plus 5. So we're going to substitute 3 in there. So you get 4 times 3 plus 5. That's 12 plus 5 is 17. This is 18. So I know this one does not work. Try the next one. 4x plus 6. I'm trying the second one. So it'll be 4 times 3 plus 6. That is 12 plus 6 is 18. Okay, that equals 18. Here's a caution, though. There are times, okay, where you put an input and get an output, and it isn't true for all of the values. So you have to be careful, okay? So you at least want to check one more. Now, you can go ahead and go with that on Khan, but remember, if you get it wrong, you got to do that many more extra right to undo that wrong. So I would suggest you do one more test, okay, to make sure it works, and that will save you a lot of problems later, okay? So try 6. Putting 6 in there, that's 4 times 6 plus 6. That is 4 times 6 is 24, plus 6 is 30. Yes, that is 30, so I know my answer then is 4x plus 6, okay? Always make sure 2 of them work. If 2 of them work, it should be right. Of course, someone will tell me sometime when it doesn't, but oh well. Here again, same thing, okay? So you're going to see which input, remember this is our input, is going to give us the 8 output for these different equations over here. So start with the 3x plus 10, putting in the 1, 3 times 1 plus 10. That is 13. That does not equal 8. I'm going to go to the next one. So I know it's not that one. 4x plus 1. So that's 4 times 1 plus 1. That's equal to 5. That is not 8. That one does not work. So 3x plus 5, 3 times 1 plus 5, that's 3 plus 5 equals 8. Okay, this is a possibility. I want to make sure it holds true for the second one as well. And 3 times 2 plus 5 is 11. That is 11. That one is my answer. Questions? Okay, let's go to the next question. Here, same problem, same process, right? Okay, so negative 3x plus 1 and negative 3 times 4 plus 1. It's a negative 12 plus 1. That does not work. Try my next one. Negative 4 times 4 plus 10. It's a negative 16. That one does not work. I go to my next one. Negative 4x plus 5. Putting in the 4. Negative 4, 4 plus 5. It's a negative 20 or negative 16. That one does not work. Let's try the next one. A negative 5 times 4 plus 20. That's a negative 20 plus 20 gives me 0. I want to make sure it holds true for my next value as well. Okay, and notice on this one, it does not. Some of you were thinking Mr. Altobelli was full of it earlier. Okay. Notice that on the second one, it does not hold true. So that means even though it was looking like this was a possible solution, that is not a solution. Or excuse me, this one was a possible solution. It is not a solution. That does not mean this last one is, because I could have made a mistake on the other ones, right? So, or even on my second check. So we'll try that one. Negative 2 times 4 plus 8. That is going to equal 0. Okay, that one checks. Let's check the 5. Negative 2 times 5 plus 8 is a negative 2. That also checks, so that one is my answer. So you need to verify at least 2 points work. Okay? Otherwise, you're going to end up doing a lot of extra con problems. Here, we're back to a similar situation as before. The first problem that we did, 2x plus 6 is my equation. I need to figure out what would it be if 1. So 2 times 1 plus 6. So that is 2 plus 6. That is 8. 8 would be your answer. The notation f of 1 here is saying for our function, if x is equal to 1, so then you would go 2 times 1 plus 6. It's telling you that we want to put a 1 in there. Okay? Again, you're going to have to start getting familiar with this notation for this next part of lessons that we have to do. I think this will be our last one. Putting in the 6. So we get a negative 5 times 6 plus 1. It's a negative 30 plus 1. It's a negative 29. Then you would put the negative 29 in. Notice it would follow in this pattern to a certain degree anyways. Questions?
So every time Z is the number next to the box. Well, X or whatever is.
Well, this, are you looking up here or are you looking here? Okay, so up here, this is saying f of x. So it's just saying what, I mean, given the different x values, what do you get when you put it into this equation? or that expression. Okay? That's what you're having to do. So you're substituting the value in. In one problem, you're having to do multiple problems. Anybody else? All right, go ahead. Get to work. Good luck. Again, it is titled Equations from Tables.